In the name of God, hello dear students. Welcome back to Think About Physics YouTube channel. My name is Masoud. I'm a science teacher. In previous lesson, we talked about the liquid property and we talked about the motion of the particles of liquid. We got some information about some unique properties like surface tension. Right now, we are going to keep going. We are going to get more information about the liquids. Let's get started. Another important property of liquid is viscosity. So we are going to explain viscosity. What is viscosity? Another important property of liquid is viscosity. So what's viscosity? Let's keep going. Viscosity is a liquid's resistance to flow, ability of liquid to flow, or liquid's resistive liquid's resistance to flow. Usually, the stronger the attraction between the molecules of liquid is, the more viscous the liquid is. So the more the attraction, the more the viscosity. The more the attraction, the more the viscosity. What's the meaning of the more the attraction, the more the viscosity? Because, and you know this information, that there's a force of attraction between two neighboring particles, regardless of its phase, actually, irrespective of its phase. Between two neighboring atoms of any substance, there's a force of attraction. But we have a very strong force of attraction between two particles of solid, right? But the attraction between the neighboring particles of liquid is a little bit less than the attraction compared to the solid state, right? That's why here it says among the liquid themselves, this force actually varies. Among the liquid, the force varies from liquid to liquid. Let me show you two different liquids. For example, we have a jam versus what? Versus water, right? In your opinion, which one has an ability to flow? Which one moves faster than the other? I'm sure you know the answer. Let's do it actually. Whenever you want to, whenever you invert, for example, I'm gonna invert the glass of water. What's the prediction? So the water flows very easily. That's why it has a less viscosity. Water has a less viscosity because it moves very quickly. So I can say the force of attraction between the particles of water is a little bit weaker than the force of attraction between the particles of jam. Or in other words, I can say there is resistance of the water molecule is low. So we have a low resistance between the we have a low resistance for particles of water, but we have a high resistance for particles of jam. So we have this case in honey as well. Honey actually looks like the jam, but honey actually is more viscous than the jam. I'm gonna invert this container actually. Whenever you want to invert it, you see, so the flow of the liquid is slower than the flow of water. So it takes time. It takes time to flow. That's why keep in mind that here we have a viscous liquid. We have a high resistance between the particles. The particles actually have high resistance to flow. The ability of flow of the jam is low. That's why it has a high viscosity. So I can say jam is viscous is, but water is non-viscous. Non-viscous versus viscous, right? Right. It says, for example, honey, you see? So you have an example of honey versus water. It says, for example, honey flows more slowly than water. What does it mean? It means honey, which one has a high viscosity, or which one is viscous, which one is non-viscous? I'm sure you know the answer, because honey moves very slowly, that's why it's viscous. But because water has a free motion, because water moves very fast, that's why I can say it's a non-viscous, let's say non-viscous. So honey has a higher viscosity than water, as shown in the figure. Right? That's it about the viscosity. I explained it. Actually, I gave you extra information, and it's enough actually about the viscosity. It doesn't need to explain more. I'm gonna leave the gas actually. I'm gonna leave the gas for the next lecture. Thank you very much for watching this video, and bye bye.